So hi, welcome to the September 21 meeting of the CNCF IoT Edge Working Group. On today's agenda, we've got one item that was a late add, and that is Kate is going to talk about using an open source project called Spin to run WebAssembly applications at Edge. Then I anticipate we'll move on to discuss this group edgenative white paper that is linked in the agenda notes document. And we might have time if somebody wants to add a late item that would be brief in time, feel free to edit it into the agenda notes document or interrupt me right now on audio and state your request. Okay, and then let's have Kate go first then with an introduction to the Spin.
Sure. And Steve, do you mind passing over screen sharing too? Because at some point I can kind of do a walkthrough demo, but feel free to hold me to time. I feel like this is a topic that we can kind of delve into longer in another session. But essentially, Shan threw out a question in the Slack that was, what is this WebAssembly on the server thing, and how does it relate to the work that we do on the edge? I recently switched companies, and I'm working for a company called Fermion that's really trying to pioneer a lot of open source tooling in this WebAssembly on the server space, which I got pretty excited about. And kind of to take, for those who might not be familiar with the idea of WebAssembly on the server, WebAssembly is a bytecode format that was made for, as it sounds, the web in 2017. And because of that, it had these characteristics that made it really desirable to then start running it on the server. So for example, because it was made for the browser, it's incredibly portable. So it had to be able to run on any browser. And so that on the server side means that it can run on any OS or any platform. It also was really secure because it was made for the browser, so it's sandboxed by default. So it only has access to things that you explicitly grant it access to. And then it's instant to start up. So we're talking microseconds to instantiate and run a WebAssembly module. So all these things make it desirable to run on the server. And because of that instant startup time, it brings out the idea of what if we could create microservice architectures with WebAssembly modules. And so kind of what you can think of WebAssembly as is kind of the next wave of computing. If you think about VMs created this first idea of how we can isolate our workloads, and containers being the second wave of how we can build these microservice architectures, and WebAssembly could be the next wave of kind of building out your microservice applications with server-side WebAssembly. And a tangent with that is the reason we have the ability to run WebAssembly on the server in a way that's uniform and community-based is because of the WebAssembly systems interface, which is, there is a organization called the Bytecode Alliance. Let me see if I can pull it up. And I'll share my screen. And so the Bytecode Alliance kind of has helped make the WebAssembly systems interface, which is a set of standards of how we can access certain system level properties from WebAssembly modules. They're kind of pioneering this work. And there's plenty of companies that are a part of this that are trying to make this happen. So that's kind of an overview of the space. Do people have any questions about that before I kind of talk about what Spin is?
Just a quick question, Kate. Would it be dumb if I asked what difference does WebAssembly make in comparison to things like unikernels?
Yeah.
Are they the same thing? Are they two sides of the same coin, or are they completely different things altogether?
I would say they're different, but maybe a similar problem space. So I think WebAssembly is very simple. And I think that's part of it, is it's just a compilation target. So you can take any language, or not any language, but a lot of languages compiled down WebAssembly. We actually have this matrix because we're kind of trying to track which major languages compile down to WebAssembly and in the browser versus on the server, following the WebAssembly systems interface. And one thing that we try and do is put engineers actively on building up the ecosystem around certain languages. So Java, for example, is super close to getting to this server-side WebAssembly, and Ruby and C and things that have an FFI interface to C can usually compile down to WebAssembly on the server. So it's very simple. You take your code and you just compile it and then run it on top of a WebAssembly runtime. So that's the executor there. So I can I'll go ahead and kind of show that. So Spin is our
Hey,
open source.
can I
Sorry,
take on his question a little more, Kate, if you don't mind? So to me, I think unikernel and WebAssembly are sort of at two different levels. So the WebAssembly gets compiled down into a runnable, portable bytecode, but it still has to be invoked somewhere. So I don't see any reason why a unikernel couldn't kick off a WebAssembly if you chose to. But the unikernel idea is sort of that you boot it up on hardware and get some piece of code running somehow, maybe without an OS, without a container runtime, et cetera. And it's the bootstrap that gets things running. That's my perspective of what a unikernel is. And the WebAssembly principle is kind of operating at a different level of taking an application, compiling it down into a form where it's extremely portable and getting it ready to run on some kind of runtime that would run it. So one is in the runtime category, the other's in kind of the application category. Anyway, back to you, Kate, and correct me if you think I stated that wrong.
No, I appreciate it. So I think kind of what you're saying is they can work in conjunction. And I think that's a good summary of it. And they're at kind of different layers of it. So Spin is something that helps you create these applications that consist of WebAssembly microservices. And so I can kind of quickly run through a setup of that if folks are interested. So we have, and then I think another question was, how do you kind of build out a platform or an application with this and manage it? So I can show Fermyon has Spin, and then also the Fermyon platform, which is open source, which kind of has a platform as a service visual. So you can see which of your applications, which of your microservices are running and kind of manage them a little. And so that can all be done by cloning the installer, the Fermyon platform installer, which executes microservice is using Nomad. So instead of Kubernetes, Nomad is the orchestrator here. And essentially a task is kind of the lowest level of a Nomad job. And that task will just call down to Spin, which is a native binary that will then execute the appropriate WebAssembly module. Before jumping into that, I'll kind of just show what Spin itself is. So all you need to do to create a new Spin application, these documents, the documentation for that is kind of the quick start here. We'll walk you through all this, but all you need to do is install Spin, which is just, you can either clone it and install cargo or a binary install. And then you can then pull down templates for what kind of Spin application you want to make, namely like what languages. So if you do, you'll see here that we could quickly create a Go HTTP server Spin application, or a REST one, or a Redis Go or REST one. And so I'll go ahead and oops. And then we can just give a project description. Simple. And then you can make a path based off of the Spin. Like when you query, then you can have different paths for each one of your microservices. So we'll just have this be at the root of the URL. But if you wanted to have multiple different WebAssembly modules that can be spun up for different endpoints, you could create different endpoints for that. So we'll just have one there, and you'll see what just came up is this Hello Rust project, and a Spin app is defined by a spin.toml file. And so this is essentially saying these are the components of this WebAssembly application. And each component is its own WebAssembly module or microservice. And so here, when we quickly spun one up, we have one, but we could add more. And this is just going to be invoked whenever you hit the base of the spin endpoint. And so if we go in and look, this is what was quickly generated, which is just a simple hello world. So what happens is when you hit the endpoint, spin will run the WebAssembly module, invoke this hello Rust component. So the key here is that in microservice architecture today, every single container that you're running has a server. It has a TLS. It has all of that built into it, and it's across all of them. Instead, with this, the spin application, or the spin binary is the only thing that has a server, and it is invoking these WebAssembly modules when it gets requests and calling the correct one and passing along any requests. So here you can see that this is just a simple, when it's run, it's going to just print hello Fermion. And so we can go ahead and you build this just with a simple spin build. And then you run it with spin up. So now we can, let's see if it has. So you can see there that in that brief second, spin ran that WebAssembly module, called its hello Rust handler, and then got the response. And so we can quickly, easily change this. And we can also add different components to our application. So things that you wouldn't necessarily think were options in the browser. For example, we could add environment variables to our TOML file. So if we wanted to, or local paths to certain files that are locally accessible. So if we wanted to set an environment variable, for example, let's just name it and give that a value of then in our application, we can just go in here and say what is the path? Oh yeah, it's just var. What was it? Some var? I think that's right. And then we can just, instead of, we'll just print that. So all right, how's that looking? Did I do anything, mess up anything there? I think we might be okay, but we'll see. And then we can simply just spin, build, spin it up again. And there we go. So you can see that you can set like server-side environment variables. We could also set a path to a local file that we could be changing and reading and writing to. So those are just some examples of kind of the microservices you could build. We could create another microservice here that could be at a different endpoint that maybe reads from that file instead of outputting an environment variable. So this is kind of just the end-to-end of how you would use spin. And then if you wanted, I'll just pause here. Are there any questions on this so far?
I dropped 3 questions in the agenda notes, but I don't know. You can catch them at the end if you like, if it flows better.
We can go ahead and kind of address them as we go.
So the first was, I was curious about the resource requirements when you run this at an edge node in terms of, I think that maybe it requires Linux. It isn't clear that, I'm guessing it doesn't require a container runtime like a Docker engine, but
So
maybe
it
you can
doesn't,
tell me.
it doesn't require Linux. It can run on, so Spin itself can run on Linux, Windows. It can run on ARM. It can run on x64. And that's because WebAssembly itself is that portable as well. So it is pretty OS and platform agnostic. So yeah, you can run it on those different types of architectures. Your other question was the runtime. So what else do I need to add to my system? So you need
Or
to
actually, I
add,
was wondering at Edge, you showed this kind of, I'm seeing an IDE and the ability to build, but maybe at an Edge node, since there's no people or operators there, I don't actually need this ability to build anything. I just need to run it. Does it emit WebAssemblies that really at the Edge nodes, then you don't need to install Spin, or is Spin an integral requirement just because it's this service that kicks off running the components that you built?
yeah, so you wouldn't need to necessarily build this. You could just move over this, you could build this elsewhere and then just, send that over to the Edge. So I like thinking about the idea of the future of what if you pass this inside the body of some sort of messaging protocol, the module that you wanted run immediately. I think that's a cool idea around WebAssembly on the server because these modules are so small themselves. So yeah, you wouldn't need to build this. You could, on the Edge, you could build it before. And then if you want to have that like microservice approach of having one server that is receiving requests on the Edge, on your Edge device, and then spinning up the appropriate WebAssembly module when it gets the appropriate request, then you would want to have Spin there running. So spinned up, I guess. But if you want to just run WebAssembly on your servers, you could just load a WebAssembly runtime. So we're using WASM time, which is the supported WebAssembly runtime from the Bytecode Alliance, and then just run your WebAssembly, like execute your WebAssembly modules there. And if they're long lasting, they could just continue to live there. But anytime you need to change them out, you would just need to manually interact with the device.
And then what are the resource requirements in terms of the minimal memory you'd need at an Edge device, minimal number of CPU cores?
So it depends on the language you're using. So for example, we have a chart here, I'm pulling it up. WebAssembly on a server has a concept of fuel, which pretty closely aligns with CPU usage. And so I actually don't know how it's converted though, what the number means, percentage of a CPU. But on the memory side, for example, a simple Rust hello world is about, these numbers in bytes. So a simple Rust hello world is about 1 megabyte, the module itself. And the part of that is that it's immediately spun up and down, so that only is taking up that memory when it's running. And then but the WASM module, the file size itself is only 128 kilobytes. So if it's not running, then there's no memory being used. The file itself is 128 kilobytes. When it's running, it takes about a megabyte of memory. And then the latency, which is, I think, what's really impressive, is how long it takes to start is in the like half a millisecond range for a simple Rust one. It gets bigger as you talk about other languages. So Go, for example, is about double on all of those numbers. And C++ is about equivalent on all of the numbers as Rust, but uses a lot less CPU. So each of the languages have different benefits to it. Let me see if do we have other ones that are worth mentioning?
So I guess a summary is that it would be viable to target a platform that say was 1 gigabyte of memory or less, which if you look at something like Kubernetes, that's getting pretty questionable as to whether you can get down to those kind of resource sizes. So
yeah, I
thanks.
think you could.
I think you answered my question. I just wanted kind of a rough ballpark of where this would fit.
And then there's also I think I mentioned this in the comment, but there is certain runtimes that are trying to be specific to IoT. So this runtime itself is smaller than WASM time, which is kind of more of the standard one, but it's also a Bytecode Alliance project. So this is something that might be interesting to look at too. But there are specific scenarios that are being explored for the IoT Edge space. Yeah. Right now, we're trying to just get people excited about WebAssembly and using it easy. And so we haven't gotten the chance to explore kind of putting this on a small sensor or on some more edge nodes and seeing what happens. But it's definitely a really interesting space to look at.
Yeah, that looks cool. I had one final question, and I think it's probably outside the scope of Spin itself, but you can tell me. And I was just curious as to how this fits into the existing cloud native or edge native packaging and orchestration systems, meaning like, I think I've heard that WebAssemblies can be put into OCI containers, for example, or are there alternate things going on that would be perhaps better for getting these WebAssemblies out to Edge? And also, I heard you mention you were using Nomad, which is one orchestrator, but I'm wondering how it fits into existing things that might be out there, or whether there's anything new going on.
Yeah. Okay. So in that kind of demo I was just doing, we weren't using Nomad yet. I was gonna show, maybe we can another time talk about kind of when Nomad is used. But essentially, if you use the Fermyon platform, then it'll use Nomad. So to talk about kind of the evolution here, a lot of the folks at Fermyon originally, some of them worked on Crustlet, which was a Kubernetes kubelet written in Rust. And I also worked on that project. And Crustlet's objective was to enable running WebAssembly on Kubernetes just as you would containers. So it made it so that effectively the only change in the workflow of an operator would be in the pod spec. The OCI image for your container instead would point to a WebAssembly module. So the Open Container Interface, I think that's what it stands for, made it so that you can have, it doesn't just have to be containers that are referenced from these OCI URLs. And instead, we also could package a WebAssembly module as an OCI image. And so that's how Crustlet worked. Crustlet became increasingly hard to handle. There was networking issues, storage issues, all that had to be implemented. And it was just not a good fit. So then we explored what it would look like to use Nomad instead. And it took like 6 days to do what was taking months in Kubernetes. And that's because Nomad has an idea of different task drivers and the ability to essentially call down to a native binary on a certain task. So we were able to essentially call down to Spin when a certain WebAssembly module should be run. So it was much faster and much lighter weight. So that was kind of the idea with why the Fermyon platform uses Nomad. There was another question there, I believe. Oh, how then do we package these WebAssembly modules? So with Fermyon, we're using an open source project called Bindle. And Bindle is another way of, it's kind of, its name comes after bundle, because it's a way of packaging up applications and all these different parts into one. There's some good talks at WASM Day from a couple years ago where they talk about a comparison between a silverware drawer and a bindle and how you have all these different things that you're putting together. Bindle's versioned. And so you run the bindle server, which sits there and receives new bindles. And then on the platform side of Fermion, which is Hippo, it will then pull the appropriate bindle and serve it up. So bindle is, oh, here we go. So this is bindle here. Did that answer your questions, Steve?
Yeah, thanks. I tried to keep up and put what I think you were saying in the notes, but maybe afterward, if I got something wrong, you can clean them up as if needed. But thanks, that was good.
Of course. And then if anyone's interested in learning more about WebAssembly on the server, there is a WASM day at KubeCon. And we're going to be giving a couple talks there, and there are plenty of other folks who are talking about kind of what WebAssembly on the server means. And so that's always a fun day around, and that's KubeCon North America in Detroit in about a month now.
Okay, just a quick question on the state of Resi. The last time I played with it, how far these integrations with the system resources got? Can you open a socket or things like that?
So with the WebAssembly systems interface, Dehan is pointing out how it's still pretty young. I believe it's like only a couple years old. So there's only so much that a WebAssembly module in the server can do. For example, networking sockets. So socket accept, the specification for that, I believe, is accepted. So for the HTTP components within Spin, it can do sockets, not accept, but socket send, it can do. So you can build an HTTP component in Rust that can, or request, I guess, that can send out a request to an HTTP server, but a WebAssembly module itself cannot accept requests because that would require multi-threading, which is not supported in WebAssembly systems interface right now. So there are certain things that are not fully mature yet. And that is one of them, is, I guess, receiving requests, but it can do outbound requests. And then there's a lot underway. So if you go to WebAssembly, there we go. You can kind of keep track of the proposals and where WebAssembly on the server is trying to be built up. So more enhancements on the IO side, file system side. And this is a good place to kind of keep up to date on where things are.
Cool, great, thanks.
Sorry, I got a question too, if I may.
Yeah, go for it. Yeah.
So that's a general question for the WebAssembly. I have never developed application with WebAssembly, but applying the WebAssembly to the Edge IoT devices, can it support like the mission critical application? Like, for example, I work on the robotics and robots and autonomous driving, this kind of stuff. So, I mean, like there's always trading off and depends on the use cases, but like in general, what would you say? I mean, like, hey, if you work on the mission critical application, hey, don't do it, or it can be applied or something.
Yeah, so WebAssembly as a technology, I would say can be put in mission critical projects in the sense that it is secure by default. There is really good security benefits to it. It's just as secure as containers, if not better. And so I think that is a big part of what is interesting to it. I would say a lot of these projects around WebAssembly are probably not the right thing to start putting in your mission critical work at the moment. I think in like 6 months time to a year time, but there isn't yet full on kind of, the ecosystem is growing so fast, but it might it might be the time to start experimenting with it and getting your hands on some of these tools so that when the ecosystem is very mature in a few years or in a year's time, you're able to kind of take the advantages of it.
Okay, so
But
as far as I see the architecture, so it requires a just-in-time interpreter or something. So it's hard to keep the real-time application. Am I right?
I like for the language needs to be a just-in-time interpreter language.
No, I saw that you said like a bytecode is generated, and I was expecting that the bytecode is loaded by some interpreter to run the application. Am I
Yeah.
mistaken?
So the WebAssembly runtime you can load it into the WebAssembly, you can load it into memory ahead of time. You don't have to do it just in time. So you could have it loaded ahead of time and executed whenever you want. That's just the way Spin does it, is we create this just-in-time WebAssembly microservices, but that's not how you have to use WebAssembly in general. You can load it into memory ahead of time and have it be executing all the time if you want.
Okay, got it. Thank you.
Yeah, I think it's common that you wouldn't translate from your language at runtime, right? I mean, in other words, if I chose to write in C, I'm not shipping C code in text down to the location where it's going to run. It's already been translated to bytecode in advance.
Yeah.
And now there's a second step that is optional of pre-translation, and that is bytecode to the actual object code of the specific CPU, you know, an x86 or an ARM. And there it's potentially the bytecodes are interpreted at runtime. But I believe there's an option to even then translate in advance to native object code if you can anticipate what the actual CPU is. So I don't think there's anything about WebAssembly that precluded that from taking place. A second thing for deterministic behavior, I think, for mission critical things might be things going on related to garbage collection of memory. You know, that was often a big limitation of Java, which was a run anywhere story, but the garbage collection of memory often turned it into being potentially unpredictable. And I don't know, I'm not an authority and don't even know the answer on where that fits in WebAssembly, whether it even tries to take on anything related to memory allocations and garbage collection.
I believe someone started looking at what garbage collection for WASI is. There's someone who's looking into that. But for languages that do just-in-time interpretation, those themselves, the interpreter needs to be compiled to WebAssembly. And so for Java, for example, they're using TVM to enable WebAssembly support for it. So there's a lot of different ways that people are lighting this up for different scenarios.
Okay, thank you.
I think we have another item on the agenda, which is discussing the edgenative white paper. So thank you, Kate. I'm sure you'll be available if anybody has more questions to respond in the Slack, but we better move on to the white paper so we have time to get into it.
Sounds good.
Thank you.
So I dropped a link to the white paper in the chat. And for those of you just joining for the first time and hearing of this, this group has taken on a goal of composing a white paper to discuss edge native principles. The purpose of this white paper is that we've observed that, you know, the CNCF has had in place for over 5 years a definition of cloud native, as a key aspect of actually the Cloud Native Compute Foundation's organization in terms of defining what cloud native means. But when it comes to running applications at edge, there have been general observations that some of the principles that stand behind cloud native still pertain to running applications at edge, but a number of them actually are called into question. Some of the things like the illusion of unlimited scalability and elasticity can be quite different when you're trying to run an application in an edge node. So this white paper is an attempt to summarize the lay of the land and maybe see if we can identify some consistent principles that would allow you to get some of the benefits of cloud native applications like portability, both across different runtime platforms, different locations, across time as your infrastructure changes, but also take into account some of the hard restrictions that you face when running at edge and coming up with some principles for best practices in addressing some of these characteristics. So we've been working on this white paper for a few months now. We're kind of at the stage where the discussion has moved down to this section that has a title of Edge Native Principles, followed by a table if people open that link and are trying to follow along. If it's useful, I could share a screen as I scroll this, but I think for purposes of being able to read it, especially since there's comments, it might be best if you're on a computer to open that link yourself and follow along. But if anybody's on something like a cell phone and can't do that, let me know and I can try to share. Okay, maybe I will, just to focus on what I'm talking about, I will share my screen just a minute.
And for new folks, it's good to point out that the top is the outline, and then you keep scrolling down and you get into the paper draft.
Okay. Okay, so here's the top that we were talking about. A lot of this was the kind of the intro notes we took as we were forming this document. So we've laid out what the scope is, what the goals are here, and we came up with an abstract and an outline. But the actual paper itself, I think there's a note saying, yeah, right here, it says paper starts here. So this was starting at what's page 6 in this document is what we'd actually anticipate surviving to be the published white paper. And we at one time had a lot of comments in this section, but I think coming here with the scope and the what is edge, that has kind of been resolved and quieted down lately. Excuse me, let me mute my phone. And then we came up with this idea that we'd open with kind of these tables that describe what's similar between edge native and cloud native, what's different. And then after the tables, we're going to move into a text format of getting into a more detailed coverage of, kind of what the similarities and differences are. We have, I think, discussed everything up to here, and we're moving on to, let me see what page this is, maybe about page 10 here. I did just add this section in the last week, so it's probably most of you would be seeing it for the first time of edge factors that constrain cloud native. It is just, I want feedback on it. It's probably too long, and I'd rather move it into a text form than this bulleted list kind of thing, but I thought I'd put the ideas there at least, and it's rough. So feel free to have at it, comment it, go ahead and edit it, delete it, add to it, I don't care. Someone else added these comments about vendor neutral pass. And I think, Dion, I think you were saying last time that you were going to add something about use of context information. If you've got any remarks about what you intend to do there or cover, or whether maybe you've added something in here and I didn't notice it, but.
No, I didn't. Yeah. So I think where we left this is that the context information for the services to access the basically the host resources, right? But I don't have any. Maybe let me do something around that for the next meeting.
So applications
do you-
addressing host resources, that what you mean by that then is the application runs at a specific edge node, and that edge node has some resources like maybe IO and devices. Is that,
Yeah.
that's what you
Yeah,
mean there?
yeah.
Okay.
Yeah, that's the difference between, in my opinion, between the edge native and the cloud native services.
Mhm.
You want to bring your compute closer to the data, and those data are probably coming from some kind of device attached to the host, right?
Right. I think in a traditional multi-tenant public cloud environment, if you were actually able to access IO devices coming in whatever server was running your application, it would be considered a bug,
Yeah.
kind of a severe security bug, because I think that might actually be the primary thing that's different about edge native, that as a goal, you kind of need to have that kind of access for a lot of these edge applications. But in a traditional cloud native public cloud environment, that is very undesirable. So they're just polar opposites there in that regard. How you do that securely is an interesting challenge. I mean, it even relates potentially to the whole thing we talked about with WebAssembly, where one of the leading edge things about WebAssembly are coming up with a mechanism to safely open up the sandbox for a WebAssembly running at edge, so that it could get to the outside world, to get to things like, that they're talking now about file systems and network connectivity. But going beyond that, there's a whole realm of getting to physical IO devices as well.
Yeah. Yeah, that's why I asked before Kate about the state of it, because I think for the edge and IoT use cases, access to devices would be a crucial thing to adopt WASI on the edge nodes, right?
Anyway, I think this document could actually use some expansion in that area. And even if it's just a statement of observing that this is heavily in transition, and these are some projects that are attempting to take this on, even if they're not complete yet, it would serve a valuable service to the community to get those things documented, so that people can go look at this document to go find some, find an initial starting point, rather than to have to open up a search engine and go do that yourself.
Do you have a good pointers? Because I mean, I found some examples and what we are using to actually access devices from the containers and from the Kubernetes pods, but I haven't seen anywhere officially documented all that. So
yeah, I haven't come across a great source for that myself either, but maybe the fact that there isn't one calls out the fact that this white paper could be very valuable, because somebody at some point in history has to be the first one to take this on. Maybe maybe this is that opportunity. Kind of,
so,
in terms of what's out there, what I've seen or what I'm using myself are sometimes mechanisms where you run something that talks to IO standalone and gets it up to a common networkable protocol, maybe even something very lightweight like MQTT. But at least then the plumbing support for getting MQTT into different microservices is at least there. Even if you had to use it within a single node, you can get that to work. And, it can go across things like Docker container boundaries and things. And it's something that maybe 10 years from now, we'll be looking at those kind of techniques as dark ages, but it is something you can use to get on the air today.
Yes, so I played a lot with the Bluetooth lately, right? And for that you need an access to actually the device from a pod or a container, and also a dbus on Linux. So those you can mount to your container or a pod as a volume mount, but you need to run in a privileged mode and things like that. So I can put what I have gathered so far in this section for the next meeting, and we can go through it, review it, and see how to fit this information into a paper.
Okay, that sounds great. Like a section that would relate to getting to things on the host. Say not only how you get to them, but any things that arise from that act related to security would be interesting.
And I think we've had discussions in the past with the container orchestrated device working group that's also within Runtime Tag about this, because they were trying to make an orchestrator agnostic way of handling devices that wasn't specific to the Kubernetes device plugin interface. So it might be interesting to kind of pull in a tidbit on that as well.
One thing, so if I'm in favor of having a section related to getting to the host resources, IO, if you will, but maybe there's other host resources that are not IO. But in addition to that, we keep coming up with this orchestration coming up, and maybe this merits a section too, that covering things like what you had mentioned in the WebAssembly portion of this meeting, Kate, of trade-offs between using Kubernetes with Crustlet versus using Nomad. I think that perhaps a section calling out the current landscape related to orchestration of applications running at edge would be quite useful to people. Maybe we can't provide the answers, and this is an area that's highly in transition, but we could at least document it as it exists today with a few pointers for where you could go to learn more about some of these projects and save somebody the effort of going on the search engine expedition.
Yeah, I think our only caveat there is which projects to be mentioned and which ones are not mentioned. Like it's going to be, some are going to be excluded from that. We're obviously not going to know all. So like some of the Eclipse IO Fog work would fit in that discussion about orchestration. I feel like what is the criteria for what we mention in that section and recommend?
I'd propose that we have a caveat overall about this whole document, that we're not attempting to be kingmakers here. We don't make, on some of these that are in transition, we're not even going to attempt to be nominating a favorite. And if people have something, they can show up to the meetings and get, if they want an entry in here, this is a public group and anybody who wants to can add it. I think that we should just have the people who are contributing note anything that they're aware of that, they would consider to be at least plausible or not ridiculous. And we'll just put them in alphabetical order rather than nominate any favorites here. But there's some value to at least listing some of them. And maybe we can call out the heading on that list just says that these are some. We won't make any claim that this is a comprehensive list, but we could do a service to the community by at least calling out a few by category so that people know they exist. And actually, if something is out there and that hard to find, maybe it isn't likely to get enough traction to be a survivor anyway.
I think we originally scoped this paper to be short. And that I was thinking with the host interfaces just to discuss the importance of it maybe maybe just the basic, but I don't know how much space do we have in this paper to actually discuss these topics in the length.
Yeah. Maybe just call out that this aspect exists and say that we'll have to cover it in detail in a future white paper then.
Yeah. But yeah, discuss basic principles, maybe add a couple of examples and call out for a future work.
Okay, well, related to resources, if you can put something there as a starting point, that would be useful, even if it isn't perfect, and we'll work on it.
Resources meaning projects, not.
Oh, I think he meant resources as like host resources,
Okay.
like
Host resources, yeah.
IO
Great.
devices and things. Okay, we've got maybe 5 to 10 minutes max. I'll open it up to other people. Oh, I'm going to stop sharing because I didn't mute my notifications here.
Have we finalized the list of principles? I feel like we had one left that we hadn't quite discussed. And when will we decide that our list of principles is finalized? Part of the reason I'm asking that is Amar and I are giving a KubeCon North America talk on this paper to kind of give an update on the status of it. And one of the things we talked about wanting to have finalized was those principles prior to it.
Well, let's just declare that this is last notice. And if it isn't, if somebody's got one to add or wants one deleted, is the table considered the authoritative list of principles? Or you tell me.
That's what I would see. I think one thing we discussed is, do we want to cut this down? Is this too many principles? 1, 2, 3, 4, 5, 6, 7, 8. That seems like a reasonable amount, but I'm curious if folks have thoughts on that.
I'm okay with it as it is because I've sat in meetings on this, at least this table's been there, I think, for at least a couple meeting cycles now. So it's probably time to either declare this to be the final or give people one more week. Either if you've got any objections to this list, either adds or deletes, go for it now.
And I do think the wording on them is not finalized. So the principal column could be, I think it's fair to say that we're not done with the like 3 to 4 words that describe a principle, but we are done with the concept of that being in a principle. Maybe we can land on that.
Well, I believe, correct me if I'm wrong, but when you give this presentation at KubeCon, I think you're still potentially going to be describing this document as a draft, or do you anticipate that we will have declared it final then?
Definitely
So
a draft.
the fact that it's a draft implies that these are subject to change. So I think just take your best shot at it and we'll live with it. And whatever you choose, I kind of have a feeling that when you convert this table to PowerPoints, that maybe just the act of having to present it and read it verbally often for me results in cleaning up the language and making it a little tighter. And I won't be shocked if that happens to you. And if it does, go ahead and alter it to match whatever you presented would be my advice.
That sounds good. And maybe the week before KubeCon, Amar and I kind of shared that PowerPointed version of the principles for a final thumbs up or down. But also we talked about wanting to maybe have this be on a GitHub, the draft version. So that is, we only have a few minutes left in this meeting, and I would propose that we do a one-off next week. And I think we need to kind of find a way to start getting paragraphs down. And I think this is going to be a grid heavy paper, which I think is nice. It'll be consumable in that way, but figuring out what needs to be written versus what is encapsulated in the grids.
Let me throw this out there as a suggestion, but you're the one who'd have to do it. So it's kind of like I'm throwing work on you. But if you wanted to, say the week before KubeCon or the next meeting before KubeCon, you could go through a dry run of your presentation because you probably want to practice it anyway, would be my guess. Especially whenever you have a group presentation, it's always good to go through a practice session with the whole group of speakers. And you've got a potential audience here who's interested in the subject. So maybe you can consider that. You're still a month away, but throwing that out there as an idea.
Yeah, definitely more than happy to do that. I think the only thing I wonder is if KubeCon has a little bit, they like the presentation to be saved for them and like their recording. So I think we would do something like just talk about the principles or something along those lines. But yeah, regardless of that, I'm curious about what we want. Do we want to have this published on our GitHub before that? Or do we want to just link people to this Google Doc?
Yeah, let's decide that later because, you know, in the early stages, we debated whether we keep this in a Google Doc or go to GitHub from the beginning. And I think there's a little more friction once it goes to GitHub of doing the changes where you've got to do PRs and things. But yeah, I think that at least a static version of the draft as a GitHub doc wouldn't be a bad idea. But we can maybe do that at the last minute, that we still don't want to start doing that now.
It might also be a good idea to, after the presentation is done at KubeCon, I would imagine you'd want to link your presentation as well. Yes. So then you can just do it then, and then also maybe just add your finalized presentation at that point in time, especially since you're basically saying that like KubeCon kind of has a thing about having like basically doing almost a pre-post prior to the event.
Yeah, that makes sense. I think it would be nice to be able to track how many people go to the paper. So in that way, it'd be nice to have it posted before. But I also wasn't thinking about how we might want to include the talk in the paper kind of for people who are more auditory consumers. And we could always update it as well with that link.
Yeah. I mean, it kind of depends. I feel like it depends on if you're, I mean, if you're looking to get some traction prior to, the question is, will there be enough that it makes it worth or justifies it?
Yeah.
And the only reason I say that is because when I was at our company conf for VMware, we pretty much posted everything at the day that we did talks. So like if we had blog posts, we posted on the day that the actual presentation was done. We also just did an open source project for one of the projects I'm working on, and we announced it. And then we made sure that the repo went live on the day that we announced it, kind of like that. So it's just kind of in conjunction with, but you know, I feel like this might be a little bit more loose on how we end up approaching it. Either way, I think it's still a good idea at the end though, just to kind of post the presentation that y'all do at KubeCon.
Yeah, that all sounds good. I like the idea of kind of posting day of kind of announcement via the talk and then also linking the talk back in there.
Yeah.
Oh, Steve, you're muted.
Oh, I think we've reached our time limit on today's meeting, so thanks everybody for attending. And I think Kate we normally only meet every 2 weeks, but I think Kate is calling for a supplemental meeting 1 week from today to continue advancing this. So those of you interested and able to attend, we'll see you in 1 week. And the normally scheduled meeting will be in 2 weeks. So thanks, everybody.
Thanks.
Thanks.
Thanks all.